This is the fifth video of the Tide Bottle project. We actually completed the bottle in the fourth part of this video series, so if you're watching this video, it's probably for one of two reasons. One is that you're not too happy with the final shape of your bottle, or the other is that you're having difficulty making the boundary for the bottle, or you are having a lot of trouble making the middle plane layout, which involves drawing several splines. This video will try to give you some tips and tricks to help you through some of the more difficult parts. First thing you want to do is always make sure that as much as possible your sketches are fully defined. So here is, for example, my layout sketch on the front plane, and we see that all my lines are black. I found it convenient to have the base of the bottle be centered right on the origin. And this vertical center line is the main center line for the bottle, which the circular label area is centered on. So this has a midpoint relation here for the base to my origin. I also dimensioned this side of the bottle to my center line, and this side of the bottle to the center line also, but independently, so there is no midpoint relation here, which allows me to move this point left and right independently of this point. That way, if I'm having trouble getting the shape of the bottle to be just right in this area, I can tweak this point a little bit without messing up what's going on over here. I have a secondary axis here, and that's what the cap and neck ring are centered on. You'll notice I'm hiding some of the dimensions off the screen here because, as I've mentioned before, my students have been asked to measure their own bottle and determine what the appropriate sizes are. It's not absolutely necessary that the bottle actually be centered right on the origin, but I find that the least confusing way to do it. Another sketch you should be careful about when you're drawing is your handle layout sketch. And again, you want to try to make all these dimensions fully defined if you can. Most importantly, all the pieces that represent this inner handle contour have to be tangent to each other and possibly, ideally, have equal curvature to each other. I've seen some cases where some people have drawn these pieces and not have them perfectly tangent to each other where they met, and that caused great difficulty when they try to form the fill surface here and the fill surface here. It would actually fail. If Solidworks is refusing to make these fill surfaces, go back to this layout sketch and make sure that all these edges are tangent to each other. The most difficult thing you will face, however, is drawing this layout on the middle plane. So let's edit that sketch. And the thing that makes this hard is that we're trying to piece together 4 different splines, and we're controlling where the endpoints of some of those splines are with some construction lines that have coincident or pierce relations to the front layout. Looking at this from the top view, it seemed to me that the easiest way to control such a complicated shape was to try to piece this all together and then have tangent or equal curvature relations between the joining pieces. But as you might have found out, that sometimes, especially if you have equal curvature between the pieces, these splines can start to freak out on you. So here's a few things that might help. First of all, our most important curve is going to be here and here, because a lot of this area and here are going to be cut out. So let me delete these right now. And I think what you want to do is draw this first and draw this second, and ideally fully define these. I haven't done that, but what I'm going to do is add some dimensions to my handles. Nice thing about adding dimensions to your handles is that you can tweak things very easily by changing numbers by very small amounts. Sometimes that's hard to do when you're just pulling things by hand. Now you see these are fully defined. The good thing about that now is if I add any new splines and make equal curvature or tangent relations to them, it will force the new splines to adjust to these splines and not mess these splines up. So now I'll draw a new spline going from this point to this point, and one going from this point to this point. And here's a case where you might experiment with just making this a single 3-point spline that goes from here to here to here. And that might actually be a little easier than splitting this up into 2 separate splines. Now I can make an equal curvature from here to here, from here to here, and finally from here to here. The good thing is, because I fully defined the 2 end splines, they aren't getting messed up by this equal curvature relation. Now I can start tweaking these handles. Well, that caused a little error there, so I'll Control Z to undo that. And if I want, I can also add an angle dimension between this line and my arrow here so that I can tweak this using dimensions rather than trying to do it manually by dragging the arrows. So I'll make that about 15 and hope that doesn't fail. So you might find that easier using these as anchors and then making these splines conform. The important thing is to try to get as smooth a contour going through here as you possibly can. Another thing that would be ideal is you want this contour to be completely outside of the contour of the base layout, which you see here in gray. It's okay if this area here goes slightly inside the base layout line, because this part's going to be cut out anyway for the handle. But if this goes too far in, you're going to have a bottle that sort of sucks in when it goes from the base up into the label area. Let's see if I can tweak this a little bit more. Well, I get an error there, but you get the idea. Now, the other thing you can do is, if you cannot get equal curvature relations added without messing everything up, you can always just go with tangent relations instead. Then when you're copying the appropriate elements for the actual boundary, use the fit spline to piece these all together into a single spline, and that will automatically give you equal curvature where these join together. So let me finish this sketch, and what I'm going to do now is make the sketch that will actually be used within the boundary itself. So I'll make a new sketch on my middle plane sketch. What I want to do is copy all these pieces from my layout sketch using convert entities. And then what I want to do is grab all of these and go up to fit spline. And I'm going to zoom in here and take a look at how well the fit spline is matching up with the original contours. And we can set this tolerance here. The tighter the tolerance, the better it matches the original contours. We don't have to go down to such a small tolerance, but we can probably go to about 0.1 millimeters, and that will give us a single spline created from the 4 original splines. The nice thing about doing it this way is that the original sketch is still preserved in the layout, and then when we copy this into this sketch here and turn it into a fit spline, we still have the opportunity to go back to the layout sketch, make changes there, and this fit spline will be automatically updated. Another nice thing about not using your original layout sketches for your boundary is that if you decide to make a radical change to your layout sketch, you can automatically update the boundary by just recopying the elements into the sketch that's actually used in the boundary, and usually the boundary will rebuild without any problems. So if you've already made the boundary and maybe you weren't quite happy with the way it looked because this layout didn't come out quite right, don't feel like you have to delete the boundary and make it all over again. Instead, modify your middle layout sketch, and then the sketch that was actually used in the boundary, you can delete all the elements that were in that and recopy the elements from the layout sketch into it. And you should get a seamless transfer of elements and have the boundary rebuilt. Now, going back to the actual layout sketch one more time, there's one other thing you can do if you're just not happy with the shape of this layout. I've been shying away from this, but you've probably been wondering why we can't just make this as a single 5-point spline. You see I'm deleting all the original spline elements. I'm going to try to make a single spline that goes through all 5 of these points. It's a little scary because when you get that many points in a spline, you start tweaking on them. You've probably found on your own that the spline can freak out pretty rapidly. So I'm going to just try this. 1, 2, 3, 4, 5. Of course, there's no problem there if you're not going to mess with the handles, but we do need to mess around with the handles here. So I'll click on this here. I need to make this handle vertical, and I need to do the same with this one here. Now this is bulging out way too much, and this is too steep in this area. So again, I'm going to very slowly tweak these handles, and this is the key here. You don't want to make any radical moves, or you might have the spline freak out or turn yellow or red. And probably the best thing to do is try to add a dimension to the angle of the control handle here. We'll make that about 60 to help stabilize this area a little bit. And we'll come over here, and again play with the handles just a little bit. Drag this one down just a tiny bit. You see very slow motions. And again, let's try adding a dimension here. And then go back again. This is actually looking pretty good. And we'll just try to tweak this handle here. And if you can manage to make this work, you'll get the smoothest result by making this a single spline. But I know it can be very frustrating. One thing that can help is turning on your curvature combs. So right-click on the spline and go to Show Curvature Combs, which is just here at the bottom of the screen, and you might not be able to see it. And here we see the curvature where the spikes are the longest on the comb. That's the tightest radius. And where it's the shortest, that's the flattest radius. So here it's very flat, here it's very bendy. And you see we have a fairly graceful transition here. It's a little bit abrupt here. We can play around with that a little bit and try to smooth out the transition of the combs in this area. We won't try to play with it too much or we'll probably mess it up. So if you can successfully get one continuous spline going here without it messing up on you, then this might actually be your best option and give you the smoothest boundary as a result. Here's the result of my boundary using a single 5-point spline going around the middle here. And we actually see this is probably a little bit better result than I had in the earlier videos. This is just blue, light green, slightly dark green, light green, and blue again. Whereas before I had some dark green stripes going through here that created sort of a more abrupt change in curvature. Another problem you might have encountered is when you first make your boundary, you'll find that the boundary surface has been split into 2 or more faces. If this happens, go back and look at all of your layout sketches, which would include the one at the neck, the one at the middle, and the one at the base. Make sure that all the pieces in the layout sketch are at least tangent to each other. If there are any lines that are non-tangent, it is likely that this sort of thing will happen. If you've confirmed that everything is tangent, then your only other recourse is to use the equal curvature to see if that helps the problem. And if you're having trouble using equal curvature, especially on this middle layout here, then leave it at tangent and use the trick I mentioned before, where you copy these into a new sketch and turn them into a fit spline. Hopefully that will take care of the problem. Now let's just say that you had gotten a bad looking boundary to begin with and it was split up into multiple faces because there was a non-tangency in a layout sketch, but you decided to soldier on and do all of your other steps and you finally got a completed bottle. You've decided to go back and fix these problems. So if we go back to our layout sketch here on the middle plane, which I happen to know has a non-tangency in it, because I purposely put it in right here, so I'll make these lines tangent again. And that will update the sketch that was copied into the actual boundary. We see here that the boundary looks nice again, it's all smooth, but some things are broken in the model. So you don't have to feel like you have to rebuild all these and then rebuild the whole feature tree. You can probably repair these one at a time. So we see the 2mm offset for forming the label surface here has failed. That's because we've gone from a two-face surface body to a single face, and that has confused things. So I'll just right-click on this, edit this feature. It's lost the two faces, and I'll just reselect the entire face of the boundary and check on that. Answer yes. And I'll roll back here just so you can see what has happened. It is now correctly re-offset that surface inward by 2mm. And now the other commands that follow that have automatically corrected themselves. So I've got a circular trim out of the boundary there, and I've gotten a trim out of the label area, which was an offset of this boundary. Sometimes another thing that can happen is a trim will fail when you repair a surface because it doesn't know how to trim the new surface anymore. And again, if you can, you want to avoid deleting a feature from the feature tree, and instead you should try repairing it. If a trim suddenly has an error after you've repaired one of the boundary surfaces, what you have to do is retell it which surface is going to be trimmed out. So I'll just edit this, pretending that there was an error here in the first place. And what you have to do is delete the sketch from the trim toolbox and just simply reselect the sketch and re-mouse over the area that you want to delete or keep. And that will cause it to reset itself again. The trouble is, when you reselect the trim tool, in this case our sketch here, you can't reselect it from the feature tree. What you have to do is make sure that that sketch is visible first, and have your sketches turned on, preferably just the one that you are concerning yourself with. And then if you have to reselect that sketch, you would first delete it here in the trim tool if this was failing, and then you have to reselect it from the graphic area in order for it to recalculate how the surfaces are supposed to be trimmed. So make sure that's turned on, and then you can mouse over the area that you want to keep, which is right here. It's much better to repair a trim than to delete the trim and do it all over again, because if you have to delete the trim and do it all over again, there's a good chance that a lot of other features further down in the feature tree will break. Well, those are all the tips that I have for this bottle, and I'm hoping that you didn't have to use any of them and that you successfully made the bottle in the first 4 parts. But if not, I hope this has helped out. This concludes all of the videos for the Tide Bottle project series.